Hemoglobin and oxygen dissociation curves. Hemoglobin is a large protein made up of 4 polypeptide chains, so it's described as having a quaternary structure. Each polypeptide chain has a heme group containing iron. Each polypeptide chain binds to one oxygen molecule, so one hemoglobin protein can carry a total of 4 oxygen molecules at once. If there were to be a fault in the hemoglobin's DNA, then the wrong amino acid would be made, meaning an incorrect polypeptide would be made, and so oxygen would not be able to bind. High affinity is when oxygen can bind easily to the hemoglobin, but it struggles to be released, and low affinity is the opposite. Oxygen struggles to bind, but it can be easily released. The role of hemoglobin is to carry oxygen around the body. Associated gas exchange surfaces load oxygen, and dissociate at the tissues, unload oxygen. Hemoglobin can be found in earthworms, starfish, insects, plants, and even some bacteria. An oxygen dissociation curve shows how saturated the hemoglobin molecule is with oxygen at any given partial pressure. And how saturated the hemoglobin molecule is depends on whether it has a high or low affinity. It's very difficult for the first oxygen molecule to bind to hemoglobin, but once it does, the protein undergoes a conformational change in shape, which makes it easier for the next 2 O2 molecules to bind to it. But then, as the hemoglobin becomes more saturated, it is harder for the oxygen to bind to it. Steep sections of the dissociation curve are where O2 binding is easy, since hemoglobin has a high affinity, but the shallower sections are where O2 binding is difficult. Sometimes an oxygen curve will shift to the left or to the right. This is linked to the affinity. If the curve shifts to the left, hemoglobin has a high affinity for oxygen. If it shifts to the right, hemoglobin has a low affinity for oxygen. The Bohr effect is something else you need to remember. The greater the concentration of CO2, the more readily hemoglobin releases oxygen. When cells respire, they produce carbon dioxide, which raises the partial pressure of CO2. Since there's a greater concentration of CO2 in respiring tissues, the rate of unloading by hemoglobin increases. Therefore, the curve shifts to the right, because hemoglobin now has a low affinity and can unload oxygen easily. So, to summarise, high affinity, oxygen binds easily and is difficult to release. Dissociation curve shifts to the left. Low affinity, oxygen is difficult to bind but easy to release. Dissociation curve shifts to the right. Hemoglobin has a low affinity for oxygen when it meets CO2. And that's it. Thanks for watching.